So the another is species area relationship. Third type, species area relationship, or in short we can call it is SAR. Now here the species area relationship, that means the greater the area, the greater is the biodiversity. Now there is one scientist from that is Germany, a German naturalist as well as geographer, known as Alexander von Humboldt. Humboldt, one German naturalist and geographer. Now he explored the forests of South America, and he came to the conclusion that, what is the conclusion? Now one conclusion is that is there is increase in species richness when there is increased explored area. That means when we will explore more and more area, the species richness, that means the number will also increase, but only to certain limit. But up to a certain limit. So this is species richness and explore area and up to certain limit. This is important point. Then the second point, according to him, is the richness. Or you can tell the relationship between species richness and area for a wide variety of taxa. Wide variety of taxa means there may be birds, mammals, plants, anything. Wide variety of taxa is a rectangular hyperbola. This is important. Then third point I am writing, then I will draw the graph. The third point is in a logarithm scale, the relationship is a straight line. So this is the conclusion derived by Alexander von Humboldt. Now let us explain it in the form of a graph. Now according to him the relationship between the species richness, when there is increased explored area but up to a certain limit, and the relationship between species richness and area for a wide variety of taxa is rectangular hyperbola. That means it shows like this. This is rectangular hyperbola. But if in a logarithm scale, the relationship is a straight line. So in that case, the relationship will be a straight line. That means like this. So this is according to the logarithm scale, the relationship, while this is known as rectangular hyperbola. So here, this rectangular hyperbola, this is S is equal to CA square, while for this the equation is But this equation is, here I am writing, that is log S is equal to log C plus Z log A. This is the equation you have to remember because it is important for examination point of view, and also you have to remember this one. Now, where S is equal to species richness, A is equal to area, then Z is equal to, that is slope of the line, or you can tell it is that is the regression coefficient. And C is y-intercept. So this is that means this is the log S. Log S is equal to log C plus Z log A, and this is S is equal to C square, where these are the different meanings. That means here the important point is this is Z, which is the slope of the line. Now usually for most of the planes, the Z value, it varies between 0.1 to 0.2 for most of the planes. But if you take the case of an entire continent having so many taxa with much diversity, then in that case the Z may range from 0.6 to 1.2. That means it will become very steeper. So in that case, what is happening, you see. Now this line is, straight line is like this, but in that case the line will be even a steeper line, like this, steeper line, because the Z value will increase. And if it will be, the line will be like this, that means there is a decrease in the biodiversity. That means the greater is the steepness, then it shows more biodiversity, and the less it is, it shows the less biodiversity. So from that, this Z value is given. Now you will take the case of one that is frugivorous bird. That is, let us take that frugivorous bird. Frugivorous means fruit eating. Or mammals. So in case of frugivorous birds and mammals, the Z value is equal to 1.15. That means it is approaching this one. That means it gives a steeper value. So this is about the that is species area relationship. So this graph and all these things are very important from examination point of view. Now the next question that comes to our mind is, that is, what is the importance of this biodiversity to the ecosystem? The importance of biodiversity to the ecosystem. So now that we'll discuss that part. Now whatever may be small or big the type of species, but it plays some role in the ecosystem. Suppose one tree known as, I'm writing here this importance of biodiversity to ecosystem. This part we will discuss. So suppose one tree frog will be extinct from the Western Ghats, or instead of 20,000 species of ants, there will be only 15,000 species of ants. 5,000 will be extinct. what it means to us. Now, when there is extinction of some species, the ecosystem is disturbed. Side by side, the survival of the human race also depend upon this stability of the ecosystem. That is why the biodiversity plays very important role in the survival of the human race. And the importance, with respect to your importance, there are three importances. One is the number one is stability, the number two is productivity, and number three is that is ecological health. We'll discuss one by one. So let us discuss first this first point is stability. Now, according to David Tillman, he made some outdoor experiments, and he found that the greater is the number of biodiversity, the more stable the ecosystem is. This is his conclusion. Why? Because if the biodiversity is greater, it is more stable. One of the reasons is if there will be slight disturbance in the ecosystem, then it can be resilient. What is the meaning of resilient? That means there will be some temporary disturbance, but it can restore itself within few months. Or it may be completely resistant to it. That means if there will be some disturbance, it may be natural or it may be anthropogenic. That means the ecosystem will be resilient or resistant, and that provides stability to the ecosystem. That is very important. And if any alien species, if an alien species means the foreign species, if any foreign species, any exotic species will come to that cannot have any foothold in that ecosystem, because the biodiversity is to a greater extent. So that is the first point. Now the second point. The second point is productivity. Productivity. Now the greater is the biological diversity, the greater will be the productivity. Suppose in the case of tropical area, in the tropical area, the biological diversity is greater. That is why the productivity is higher. While in temperate areas, the biodiversity is less and the productivity is less. So in that way, that has influence on the ecosystem. And the third point is that is ecosystem health. Ecosystem health. So this is one of the very important points, that is the ecosystem health. That means if from one ecosystem, if some of the species become extinct, then what will be its effect on that ecosystem? So this has been very clearly explained by the Stanford ecologist Paul Ehrlich, Stanford ecologist. Now, how he explained it? He took an analogy between an ecosystem and one aeroplane. In the ecosystem, there are different types of species. Similarly, in the aeroplane, the aeroplane is constructed by fitting with different types of rivets, means nut and screws. And the name of his hypothesis is known as rivet popper hypothesis. Rivet popper hypothesis is very important for examination point of view. So the aeroplane, the different type, the steels are fixed with by means of these rivets, which are the nuts and screws. And Suppose somebody while sitting in the plane, he will remove one or two this rivets, then it will have not impact on the safety of the aeroplane and it can safely fly. Suppose 8 to 10 people, they will take these rivets, somebody from the seat, somebody from the luggage box or somewhere. It will have no impact on the plane, on the flight, because it has no effect on the engine or the wings. In the same way, from the ecosystem, if certain redundant species means which are not much important, if they will be removed, then it will have very less impact on the ecosystem. But if in the aeroplane somebody will pop up some rivets from the wings of the plane, that means from the wing flaps, somebody will remove the rivets. What will happen? That means the aeroplane will be open to the atmosphere and immediately it will lead to accident. Now you apply this method to the ecosystem. In the ecosystem, if few redundant species, that means which are not much important, they are extinct, the ecosystem has less impact. But if a keystone species, what is the meaning of this keystone species? That means the number is less, but it has more impact on the ecosystem because it has a lot of influence. And one of the example is tree frog. Because these are the plants to which large number of birds will come, then they will move here and there, they will pollinate the different types of plant, flowers. That means they have more impact. So if a keystone species like a tree frog will be extinct, it has a great impact and the entire ecosystem will collapse. Just as if some rivets from the wing flaps will be popped up, it will lead to accident. The same thing happens if some keystone species like a tree frog will be extinct from the ecosystem will collapse and that becomes a danger for the survival of the human being. So this is all about this patterns of biodiversity. Now let us discuss questions. So one question, Alexander von Humboldt described for the first time law of limiting factor, second choice species area relationship, third one population growth curve, and the fourth one is ecological biodiversity. So this question was asked in NEET 2017 and we have discussed this just now. The second one, the species diversity describes or decreases from lower to higher altitudes on a mountain. This is due to This is due to first choice, increase in temperature. Second choice, decrease in temperature. Third choice, greater seasonal variability. And fourth choice is both B and C. And this question was asked in AIMS 2014. So both the questions you can answer as we have discussed all these things, and these are the type of questions which are asked. Now I hope this patterns of biodiversity is very important and very easily you can understand it once you go through the video. So thank you very much for watching the video. Wish you a very bright future. God bless you.